In this continuing series of lecture on the reinforcement detailing of the various RC element in a structure, I will be covering the reinforcement detailing requirement of the RC slab in this particular presentation. Now, going ahead, the reinforcement detailing of the slabs are done based on its support condition. We will now discuss the important aspect of the slab detailing in our lecture. Now, first coming to the detailing check, we have to basically understand how the slab reinforcement detailing is carried out in case of a continuous slab or a one-way slab as well. So, let us see in the first figure what I am showing. So, this is the discontinuous edge, this is the continuous edge. Here you can see the main ST or the ST1, that is the main ST of the slab, should be provided at the bottom. We have to ensure that all together at every time on the side the bar binder does like this. The main reinforcement should be provided at the bottom and the distribution steel should be taken above this. Many a times the bar binder does the mistake, they provide the distribution reinforcement at the bottom and the main reinforcement on the top. That is not recommended to be done at the side. Again, coming for the bending up of the bars, that is the main reinforcement, we have to ensure that whatever the main reinforcement is coming, the 50% of the same is taken inside the support, and 50% of the bar should be cranked up and taken to the top, and the distance should be followed like 0.15 L, where L is the span of this slab, and 0.15 L the bar should be bent up and taken top. As such, this distance from the face to this bent up portion is remain 0.1 L at least, should be more than in fact 0.1 L. So, similarly, at the continuous edge, so this is a continuous edge where the slab continues further inside this span. So, here what you have to do, we have to ensure that 50% bars are allowed to continue inside this joint and 50% bars should be bent up and taken to the next slab span. What would be the recommended distance as per the code is that at a distance of 0.25 L1 from the center of the right hand side of support, 50% bar should be bent up, and the same bar should be taken and extended to the next slab up to a distance of 0.3 L2, where L2 is the span length of this particular slab. So, similar manner, whatever the bars are coming from the right side, they should be given a bent up at 0.25 L2 and should be taken up to 0.3 L1, where the L1 is the slab length of this span. So, accordingly, this is first setup of using the bent up bars, where in the second setup we can see we are not using the bent up bars, we are providing the straight bar. So, similar type of setup has to be followed in this case as well. So, similarly, the bars whatever is coming, 50% should continue at the bottom and 50% should be taken to the top, and all together all the distance like 0.1 L should be maintained here, 0.3 L1 should be maintained here, 0.3 L2 should be maintained here, and the bar whatever the 50% is getting curtailed, you should be following the same distance of 0.25 L2, 0.25 L1. So, this is the basic standard of doing the reinforcement detailing in case of the slabs. Now, coming to the placement of bars at a slab support. As I was mentioning, the correct detailing requirement of the slab in the first slide, we can here see what the bar binders usually do. They generally give a bent up at this location, but leave this bar at this junction. They think that okay, they have given a bent up here over here or crank the bars over here, and just they continue up to this one only for the namesake only. Similar thing they do at all the junction, and we have to enforce this on the side कि whatever the bars are getting cranked up, they are taken at least 0.3 L beyond the support. This has to be ensured at every joint. You should not leave, or you should not be checking only one or two joints. You should be checked at all the joints कि the extended portion is taken beyond 0.3 L at least. Now, the placement of bars in the cantilever slab. Cantilever slab is altogether a very crucial point in any structure. So, we have to perforce put our focus while detailing or checking the detailing of the cantilever slab. So, here we can see what the bar binder generally do is like this, they take this bar to the top and continue as the main reinforcement of the cantilever slab. They never think about the anchorage profile or the anchorage requirement, what is actually required for the cantilever slab. So, we have to check this profile while doing the side check of the reinforcement. So, what basically we have to do, again similar case, In case that is a cantilever slab, again we have to bend off this bar at for distance point to L, where L is the span. We have to take this bar to the end of the reinforcing bar. 50% bar should continue up to here, 50% should be taken to the top of the cantilever, and in the gap we should be providing additional bar. Those additional bars should be at least a distance of 0.3 L inside the continuous slab. This needs to be done, and the additional bar should be extending to the end of the cantilever slab. Now, again coming to the issue of mixing of the bars in the two-way slab. Many times we generally design by giving a TOR steel of 50 or TOR of 40. TOR 40 means Fe 415, TOR 50 means Fe 500. We should not be doing this kind of thing while doing the detailing or the design, because it will create utter confusion among the ground executive. Nobody would be able to follow in case of any change of specification of the reinforcing steel. It will altogether get mixed up and defeat the purpose of doing the design. So, better all the grade of the steel should be similar in any kind of structure. Now, coming to the arrangement of bars in the one-way slab. So, here we can see one important aspect we have to see over here, though we cannot find any fault in this figure. I am just showing what the fault lies with the bar binder. The reinforcement in the one-way slab is that the shorter span is the major bending direction, and the bending takes place along the shorter span. That means, the main reinforcement should be coming at the bottom of the reinforcement cage. So, here you can see the mistake they have done. They have taken this main reinforcement above the distribution steel without understanding the repercussion we can have out of this methodology. So, we have to ensure in case of the any slab, be it a one-way slab or two-way slab. Now, coming to the detailing in case of the staircase. In case of staircase, we have to understand the behavior of the staircase or the waist slab under the loading. So, here in the left side figure, we can see how the waist slab behaves under the loading. So, this straight line portion that indicates the starting position, and this dotted line indicates the loading position. So, here we can see how the slab is now bending like this. You can see this location and this location, the tension is getting developed because of the bending. So, we have to arrest this tension, otherwise it will lead to the formation of cracks in our actual structure after construction. So, to resist this tension, what we have to do? We have to provide the tension lap. Now, you can see this bar is provided or taken beyond this, which is called the tension lap. That may not be the requirement of the main steel, but to give the tension lap, this bar needs to be extended up to this. So, here in the case we can see this is the tension lap that is given, this bar is taken here and given a bend, that is the tension lap. Similarly, this bar is taken and bent over here, this is the tension lap. That means, under the load, when this joint is opening up, now this tension lap is going to arrest that load and resist the cracking. And now, coming to the detailing aspect in slab spanning in the different direction. So, in a particular building, there used to be many spans or the many rooms covering, and the slab covers almost many rooms or the many span. But actually what happens, people fail to understand the direction of slab. Suppose this is a one-way slab, this is another one-way slab. What happens for this one-way slab? We provide the main reinforcement at the bottom, as I already explained in the earlier slide. But bar binder, what they do? They continue this bar into this one as a bottom bar. When this bar is getting continued inside this span, now it is again, it should be becoming actually the distribution steel for this slab. But when it is taking at the bottom, again it is defeating the sole purpose. We can see the main bar of this slab should be actually coming at the bottom, and the distribution steel should be coming at the top. Whereas, if the bar binder is allowed to continue this bar like this, it will be solving this purpose of the slab, but won't be solving this purpose, bending purpose of this particular slab. So, we have to perforce, we have to ensure, we have to first understand in which direction the slab is bending and what the structural designer is actually showing in the drawing, and you have to follow this one meticulously. Again, you have to ensure whatever the reinforcement that is crossing this and coming to the next slab, it should be at least given a 300 mm length thickness inside the next slab in this direction, and this bar what is coming, that should be given in this direction. So, with this I conclude this lecture. Thank you.